Okay, good morning, good afternoon, good evening, everybody. Welcome back again to the day two training. Module two is talking about preventing and mitigating the environmental and public health impacts and associated gas processing and treatment. We will go over a few points here. They are all related to environmental and social liabilities of associated gas treatment. We will look at the best available technologies to prevent the potential or mitigate the potential environmental and public health impacts. We'll talk about the waste sources and contingency planning. Example is sulfur. We will also talk about some case studies almost wherever we go in the operation itself. So we will describe the issues and what kind of impact on social health and safety. Where can we find or where can we get an alarm about the waste? Where is it coming from? Potential, the major points that is potentially creating the waste itself. We'll categorize them, try to find the possible solution, and of course, in case there is an upset in the process or there is something that goes right or left, we can have a contingency plan with the accidental gas leaks. Let's go back to the definition we had yesterday. It's all about atmosphere, land, water, plants, animals, and any other organisms. I like to categorize it as well as humans, water, air, earth, and our living partners. Again, we are not living alone, so we have to take into consideration the atmosphere and the living organisms around us. So a general idea about pollution. So what is pollution? Says here it's a substance or type of energy. So let's pause for a sec here. How come energy is a pollutant? Like, is it true that energy can be actually a pollutant? Of course. Pollution is not only a chemical pollution. We also talk about thermal pollution here. We have different types of pollutions according to the most recent definitions of this word. It's either a substance, right, or leak in energy, because the leak in energy is considered to be a pollutant as well. What else we can consider here? Well, for oil and gas, we are more interested in substance and energy, but for other industries also, they are talking about noise pollution. Okay, so if I want to generalize, I would say pollution is any undesirable byproduct or effect coming from the process industry. All of those can affect the environment in different scenarios. They can affect the environment in different modes. But in general, we are more concerned about the 5 pillars for environmental protection. Air is one of them, land, water, humans, and as I said, other living partners. What about air? What may happen in the process of associated gas can affect the air? Well, the gases, of course, like sulfur, like NOx, SOx, as they indicated in the quiz and previously in module 1, we are also talking about greenhouse gases. Those are possible waste streams. Okay, where can I find them? Well, everywhere. You can't find a leak in the process everywhere. Let's remember that we are talking or dealing about with machines. pipes, pumps. We are also talking and dealing with compressors. Yes, I agree. We are actually implementing those machines and techniques to clean up the gas. That is wonderful, but there is also a possibility of process upsets. So I would like, or I appreciate as well, if we can look at associated gas from A to Z, from the minute we drill for it all the way to the pipeline. And even in the pipeline, we still need to watch and monitor those possible waste streams. General review, please. Drilling, casing, workover, as I said in module 1, up to the Christmas tree. And the Christmas tree, for for you guys, if you are not aware of it, it's the valve. Let's think about it as the valve on the surface of the earth. Once you open that valve, the associated gas will come out and can be processed at the surface. The process itself is mostly everything or every piece of machines and equipment that can deal with associated gas and clean it up, make it ready for the next stage, which is the transportation through pipelines all the way to the points of use. So wherever you are using it. Now, as we spoke about on module number 1, most of the companies that they drill and maybe process, they do not own the pipeline. So there are requirements by the pipeline owners and operators to receive a certain quality before they can accept it in their pipelines. If we are talking about the surface facility, we start with the 2-phase or 3-phase separator. That is where you'll find lots of, well, basically this is the first equipment that will receive all the, I would say, problems. Okay, so if it is a 3-phase separator, you should expect some sort of water, oil, gas mixture. So you have 3 phases here, and they all come together to the first station, which is the 3-phase separator. Okay, what will happen there? Well, of course, gas will go to the top. Oil will be in the middle. Water will be in the bottom. What about solids? Shall we expect some solids like sand coming out? Well, there are some. And look at water and gas. What will happen? Well, if water absorbed a little bit of sulfur dioxide, immediately you're talking about sulfuric acid. Wow, what will happen then? Well, it will eat the metal. Sulfuric acid will immediately eats the metal, and of course, eating the metal means you'll have leaks. Solids as well, they are abrasive. They can, they are very erosive to the metal itself, regardless what kind of metal you are using. And the heat losses there might be significant as well. If I am sitting in a regulatory office and I received project initiation from an operator that, you know what, we are handling associated gas project, and this is how it works. The first thing I would like to see is the block flow diagram. Block flow diagram is not complex. It's like blocks. It tells you what is first, what is second, what is third. And at every single block in that diagram, I take notes. Okay, possible waste streams. Okay, where can I find, where can a leak happen? Wonderful. What else I need to look at? Well, I need to know what's in the associated gas. Of course, the operator took a sample, they analyzed it. They will give you also the operating pressure. they will tell you, well, the gas coming from XYZ field is with the following components. Let's look at the components. For the regulatory, for different regulatory bodies, the components are very essential to determine where should I keep an eye? Where should I focus? So the block flow diagram will identify first which one is first, which one is second, and so on, till the end of the process. So we identify the components. Let's say I notice that there is a high sulfur content. Okay, that's an alarm. So I should expect some leaks in the process that may end up with a sulfur problem. Okay, what else? Well, we have water. Oh, great. So if we have water, then there is a possibility of a reaction. There is a possibility of strong acid formation and or weak acid formation. Oh, what's a weak acid formation? Well, the weak acid formation, well, we all know about the strong acid, which is in this case, sulfuric acid. Okay, what about the weak? Well, CO2, for example, and water can form a weak acid, carboxylic acid. And this weak acid, yes, it is weak, but with time, it can cause and create a major problem for the process. So in my components, do I have CO2? Do I have sulfur? Do I have water? What is the relation between all of those components when I find them in the same place? Okay, what else I need to look at? Well, leak from the gas. Okay, what about the leak from the liquid? Well, there will be, remember that we have oil droplets. So there might be a leak from the oil phase that will end up having a situation in contaminated soil and or spills. Okay, well, that's a possibility as well. What am I going to do with the water that comes out from this block? So the checklist probably that we created yesterday can give us a clue and an idea about what should I expect. And accordingly, the regulatory officer has to have his own checklist according to the block flow diagram that he or she is currently reviewing for a certain process. Very important advice here that I got from one of my mentors. He said, keep your notes for at least 7 years. Because based on those notes, you will take a decision. And accordingly, after 3-4 years, and if you are handling 3, 4, 5, 6, 10 projects, you will forget. So those notes are very essential to bring your memory back to the points that you considered while reviewing a certain project. And it is regardless, are you a regulatory officer? Are you an engineer in the field? Are you a designer? It doesn't matter. So in the air, there are few things that we take care of. We gave an example of SOx and NOx, but again, we are talking also about CO2. I still remember the questions from yesterday. What about heavy metals? What about benzene, toluene, all of those kind of contaminants? Now, also for the land, we should expect some spills. For the water is not going to be clean. Okay, what's the plan? And let's remember that the process facility has auxiliary units associated and attached to it. Okay, like for example, the sewage, the drinking water, the energy needed to operate all of those equipment, they need electricity. So how am I going to generate this? And is there any waste that I should expect from those auxiliary units. So yes, the officer will focus on the block flow diagram, which must include any auxiliary, I would say, equipment attached to the process itself. Now, air pollution, is it human-made or is it natural? Well, this is $1 million question. Like lots of processes and lots of operators, they will say, well, we cannot help it. It happens. And I agree, it will happen. The air pollution I'm talking about. So if it's an introduction of harmful materials into the atmosphere through human sources, human activities, human mistakes, then that's an air pollution that we call it human-made. Common industries that can generate such human sources. I'm giving an example in Alberta, Canada. We are talking about gas processing plants, refineries, and power generation plants. Of course, it depends on each country, but generally speaking, those are the major three in Alberta. We have also the natural sources. Natural sources of air pollution also exist. Volcanic activities, weather activities, depends again on the country, depends on the location. That's why it's very important to understand that each project, even if you are talking about the same area or even the same city, each project should be handled separately, depends on the location of that project. And I'm glad to see on the sticky notes that we've been through this morning that lots of takeaway from yesterday was the permit is attached to the location, not to the company. Great. If you have that in mind, wonderful. Now, how do we actually monitor? How do we actually make sure that the waste identified is well taken care of? How am I going to be sure that, okay, this operator will find a way to cure and fix any possible problem? Well, the concepts are very easy. You have the concept of the SEMS, which is continuously measure emissions from stationary source. So is it stationary source, the associated gas processing facility? Definitely yes. If you put a pump there or a compressor, most likely it's a stationary source and it will remain there till the end of the project lifespan. Examples of measurements, of course, we are talking in general about SOx, NOx, CO2, oxygen, TRS, which is the total reduced sulfur, particulate matters. Okay, so where am I supposed to see those waste in the process? Again, let's go back to the block flow diagram. And on each block, I will identify what can go wrong. Where do I need the monitoring to be? Do I need it to be continuous, or am I happy with periodic tests? Now, I made a little note here about inspection. So where should I arrange an inspection plan? Again, as a regulatory officer in a regulatory body, I should have a periodic visits to the site to make sure that everything we, like you and as a regulatory officer, approved before and recommended before is basically followed. So inspection is not like policing. It's not like trying to find a problem. No. Inspection goes along very well with the permits that you are offering. Of course, the permit, once the permit is issued for a certain project, there will be some conditions. Like this permit is approved based on the following conclusions. but the operator has to take into account the following points. Your friend and very close friend in any permits, any regulatory step is the block flow diagram. Okay, don't go beyond that, like the process flow diagram or the PNID. That's not important. Well, it is important for another officers, but for a regulatory officer, the main source of information will be the block flow diagram. Okay, so the inspection has to happen at the following points. It's part of your responsibility as a regulatory officer to advise the regulatory body with an inspection plan. How can I make sure that the permit that was given to this operator is followed? Kindly and please remember that you are not policing. You are trying your best to protect your country, to protect air, water, human, earth, and so on from any process upset that may happen. And guess what? It will happen. The process upsets are there. You cannot prevent them. That's why you should have a mitigation plan, as we agreed on yesterday. Typically, those concentrations of whatever the waste is, the concentrations are measured in ppms, part per million. What about the percentage? Well, if you have a concentration in percentage, then guess what? You have a major problem. Well, actually, if the concentration is in percentage, I think the project has to stop. So we are talking about part per million, and sometimes we are even talking about parts per billion, okay, which is 10,000, like 1% is 10,000 parts per million. And I'll go into the list in a minute, converting the percentage into ppms and vice versa. But in your block flow diagram, you can, as notes, you can say, okay, this is a possibility for leak of the following compounds. Let me remember the standards. Okay, you open up your standards book and you say, okay, what is the acceptable limit for CO2 here? Well, it is 1 part per million. Wonderful. So you write it down and you make sure that the inspection report is and has the standards and the minimum maximum limits of whatever standards you are following. If you don't have those standards, what shall you do? For example, I'm handling a new project, and in this project, there is a possibility of cyanide, cadmium, heavy metal, and I don't know what is the standard for that, as it is not mentioned in the country standard. Wonderful. You initiate the step of reviewing the standards. That's number one. And my advice is to go to the nearest country, okay, and check their standards. What do they say about that particular waste? Do they have a limit? Okay, wonderful. If they have a limit, adopt the same limit. And of course, you have to go through the approval process for those limits. Tell your standards, your country and local standards are modified and updated to include that particular waste. Every project is unique. Every waste is unique. That's why we have always to update ourselves with the most recent limits adopted by the United Nations, adopted by your neighbor country, adopted by the industry experts. And who can help? Again, the universities, the research institutes can help you identifying and can help you putting the standards that are not reviewed yet. So for the countries where we don't have a standard for a certain waste, check with the nearest university. They can actually initiate the research and they will get you the standard updated the way it is in the rest of the world. Now, we also, like in Alberta, we also use the mass emission calculations. So in Alberta, we say, okay, we are allowed to flare up to 1 ton of sulfur a day. It's okay to do that. Okay, well, that is in Alberta, Canada. Remember that we are talking about a country that the temperature can reach -50. Okay, so it goes as high as 35 degrees Celsius, goes down to -50 and even sometimes to -60. So the limits that are adopted by a local country should match and go along with the climate, with the need, with also the general overall situation of that country. If I am talking about a country full of natural habitat, it has reserves and full of those lovely species about animals and certain types of trees. Of course, the limit that I can adopt in this country is different from the one I'm adopting in Canada, for example. So what about the ambient monitors? The ambient conditions, how can I monitor that? Well, most of the time, the ambient is for the surrounding conditions. And those are taking as low as part per billion, not even part per million. Let's remember that each country is unique, each project is unique, each location is unique. So we have to plan our activities accordingly. This is a quick review for the how to convert from percentage to ppm, from percentage to PB, from and vice versa. It's just if you want to take, if you want to keep it in your mind, just have it as 10 to the -4. 10 to the -4 is the golden number to convert between percentage and lower concentration. One clever person came and say, okay, we have pollutants, we are exceeding the limit. Wonderful. How about if I disperse those pollutants high in the sky? All what I need to do is just make the flare high or just make the stack high enough. So you know what? All of those pollutants will go to the atmosphere and it will be high enough. Nothing will happen on Earth. It will be dispersed far away from the living spots. Well, this clever person is following the golden rule of dilution for pollution is a solution. Okay, so if I dilute it, it's not a problem anymore. Okay, and this is actually as part of the regulatory officer responsibility is to make sure that dilution for pollution is not there, is not part of the mitigation plan. Because dilution is not a solution. It's basically what you are doing is you are delaying the problem for a later stage or a later point. Of course, the stacks, they do release effluents at high velocity and a high distance above grade. And those pollutants will mix with the ambient to lower the concentration. And this, again, we are talking about standards. So now we are below the standards. But what will happen if your country is cold as it is in Calgary and in Canada in general? Well, those pollutants will come back. They are not going to be they are not going to disappear. in the sky and easily, and then you forget about them. The concept of cold air trapped below warm air is always there. So in case you have a situation like this, then you are not actually solving the problem. You are creating another problem that I will talk about in a second here. Let me remind everybody that each country is unique, each project is unique, and each location is unique. Now, talking about the weather conditions, whatever applicable and acceptable in Canada may or may not be acceptable in your country. Why? Because the weather conditions are not the same. Basically, one of the reasons. So whatever they are doing in Canada, I should investigate it a little bit more. Now, why this is important? Like why we are talking about different countries and different mitigation plans in every country? Well, most of the operators that I am aware of, they work in different countries. If I want to take one of the big players, you can find that player in Canada, in the United States, in Africa, Middle East, Europe. So what they will do is they will come to you as a regulatory officer and they will say, oh, don't worry about the mitigation plan. We will utilize the same one we are using in Canada. And as you may know, the Canadian standards are the worst and the heaviest to deal with. So if we are approved in Canada, you should approve us as well here. Well, not always the case. Canada is different from my country. So if your mitigation plan is approved by the Canadian regulatory bodies, it's not necessarily that I will approve it without thinking. I still have to do my homework. I still have to look at the mitigation plan, compare it to the situations that I have in my country. Again, you are not making the operator's job difficult. What you are doing is you are protecting your country and you are protecting your people from getting problems that you don't want them to be in. This is a very schematic sketch about what we were talking about in terms of air and dispersing it high. If you look at this part, this is the stack. The wind will take the fumes away, and the blooms, we should expect them to go up, okay, in the sky, and you know what? They will disappear. Here we are talking about cold versus warm air. If you have this situation, look at this photo. This photo speaks about a situation where that clever person who decided to build a taller stack or a taller flare to disperse the polluants away from the grate, it will come back. This is how it will look like in a typical day in Calgary, Alberta, Canada. Okay, now imagine if you have a high concentration of sulfur in this, let me call it fog for now. So this fog has a high sulfur content. Now, what will happen if you have a rain? If you have, by the way, what will happen to your habitat? Like let's remember that we have lots of partners living in the sky. Those partners like birds and other creatures, what will happen to them if they actually drive through this situation? High sulfur content, high CO2 content. What else we should expect? Well, we should expect some water vapor. Okay, what will happen if you have water vapor and sulfuric or carbon dioxide? Immediately you are forming some types of weak and strong acids. Wow, that means you are living in acidic environment. And of course, you guys can expect what may happen after that. Contingencies and versus emissions. So emissions must be taken care of during the design stage. No doubt about it that the block flow diagram I talked about earlier is your best friend. You took a look at it, you evaluate the emissions and the spots where those emissions may happen, and accordingly you take a decision when it comes to the mitigation, when it comes to the inspection, when it comes, of course, you compare them to the current standards and the local standards you have. Don't worry, there will be no problems at this spot because we are taking blah, blah, blah measures. No, emissions and leaks will happen. They will happen. They are there. So you will not believe if I will tell you, no, I'm using this type of metallurgy, I'm using this type of technique, I'm using this type of technology that will actually produce no emissions. Forget it. Emissions are there. There will be a minimum and maximum. You should compare those to your standards, and then you take a decision. Possible emissions must be identified, and accordingly, a contingency plan should be in place to handle those emissions. What else can happen? Well, upset process conditions, especially and mainly at the compressor station. So if you have a compression station or you have a compressor in your block flow diagram, that's basically one of the spots where you have to open your eyes and focus a little more. Upset conditions are always there in the process. They always happen. So you should have a plan, a contingency plan on how to fix those. All upset process conditions must be identified at the beginning. When I say at the beginning, I mean the design stage, the construction, and of course, during the operation itself. All of those has to be fixed and has to be, of course, identified first. Then a contingency plan has to have ways to handle them. What else we need? Well, you need the standard operating procedures. You should have your SOPs in place for a better monitoring and mitigation techniques. Now, I always remind myself that SOPs, once they are drafted and they are in place, most of the time we just shelve them and forget about them. No, SOPs are living documents, and those has to be updated as per operation variables. The quality well, as engineers, we say the efficiency. So the efficiency of any equipment in the field is proportional to the time, okay, as everything else. The efficiency of any equipment will vary with time. The more you use it, the less efficient it might be, okay? Now, what will happen if the efficiency is dropped or the quality of that equipment is actually dropped? Well, you have to identify this in your standard operating procedures. Like after 3 years from now, we have to check so-and-so in the process. And let me remind you, your block flow diagram is always sitting beside you when you decide which points you have to revise and when. So contingency plan goes along very well with your design stage, construction stage, and operation. Well, what about the commissioning stage? What about the setup, startup stage? Well, those are also a possibility as well. And of course, again, we go to the process upset conditions. We have also to take those into consideration, what may happen and when, and of course, where. Talking about safety approach, well, general rule is safety is everybody's responsibility. Okay. Well, I both the operators and officers in field, I bought them the personal protection equipment so they are safe. No, PPEs are not enough to assure safety. Okay, they are a step, they are part, but they are not everything. We should always have instrumentation in place to make sure that the place is safe for people and it's always safe for the environment. We are in an era of high-tech tools around us. So let's utilize those tools and make sure that the workplace is safe and environmentally friendly. What are the measures we take to make sure that this project is safe and environmentally sound? One of many ways is to choose the best available technique or technology for your mitigation and the reuse, and of course the safety approach as well. So what does it mean? Well, I have a problem, which is a possibility of contaminant. And we said it will happen, it is there. Okay, so how do I handle it? Well, you should handle it from now on in a way that those pollutants and whatever the waste you are talking about is not a waste anymore. It's a commodity. You are not supposed to be overwhelmed because of the existence of this contaminant. We need to choose the best available technique or technology to mitigate. Yes, that's number one. Of course, I want to mitigate it. But if it happens, and again, it will happen, how can I reuse it? Is there a possibility to reuse? Is there a possibility to convert the waste into wealth? Okay, well, if there is a technique that I can use, bingo, let's go and use it. As I indicated in module 1, waste in general has now profitable solutions. The choice of your best available technique or technology depends on the waste stream handled. Okay, so how can I convert the waste into profitable commodity? There are techniques, there are technologies available now that will take care of that. As an example, we've been through the CO2 together in module 1, and I'm repeating myself here. CO2 can be captured and reused in different applications. One of the applications, which I don't support, but one of them is to re-inject it for enhanced oil recovery. The other technique is just collect it and produce methanol out of it. There is a mature technologies that can convert CO2 into methanol. And again, methanol is a commodity that has a price. In Canada, it sits at $1.2 a liter. So this is actually a waste with price, let me say so. So sulfur, we talked about sulfur reduction. We talked about utilizing the sulfur in fertilizers. Sulfur is a major commodity for each and every single industry that I saw, starting from oil and gas, going to food and beverage and beyond. Of course, the NOx, the nitrogen, which I support in terms of re-injection for enhanced oil recovery. Those are just examples. Water waste that may come from associated gas, it definitely has some heavy metals in it. If I can recover those heavy metals, then I'm hitting two birds with the same stone. First, I'm cleaning up the water, plus I am producing a high demand, high priced commodity, which is the heavy metals. Several examples will be given in the handouts, and of course, your block flow diagram, your gas analysis, that will tell you more about what type of waste you should convert into wealth. Always recommend a mitigation plan by reuse. Always recommend it in your discussions with the operators. So tell them that I identified this contaminant, but guess what? I also identified a solution, a profitable solution. Now, this is what one of the participants call it when situation. So everybody is winning. As I said, the CO2 for reinjection is one of the main enhanced oil recovery techniques. One of the sources of CO2 is the amine unit. And how do I actually explain this, the CO2 capturing? Like, I capture CO2 and then I do what? Well, re-inject it in the well. Okay, where is that well? But remember, you are dealing with associated gas, and associated gas is identified as the natural gas that comes along with oil production field. So if you catch that CO2 and you re-inject it in your oil well, wow, that's great. That's wonderful, because you are talking about a waste that you converted to a profitable product. And there is not much of distance between the capturing and the re-injection, because we are talking about the same geographic area. So it's not like you want to push the CO2 from city A to city B, and that's about 300 kilometers. No, we are talking about the same area here. So you do have the waste, you converted it to a profitable commodity, and guess what? You have the use as well at your doorsteps. So you can solve the problem, create a commodity, and create a use for that commodity. CO2 is one of the identified profitable commodity that was identified as a waste before, but now we are talking about it as a commodity that we can use always. The source of it is the amine unit. It doesn't mean that we cannot find it anywhere else. No, we can find it almost everywhere, but the amine unit is the one that has the high concentration of CO2. When I talk about best available technique or best available technology, in terms of what? Well, in terms of maximizing my CO2 capturing. How can I achieve this? Well, you can achieve it either by the hardware that you are using, which is the equipment, or the chemicals you are using. So in my case study here, I'm talking about introducing a new solvent. This solvent will absorb more CO2 from the associated gas, and the CO2 can be recovered faster and easier from that solvent. Because remember, the solvent will absorb the CO2, and then we have to separate the CO2 from the solvent, capture the CO2, recycle the solvent to get us more CO2 as well. We also can identify other points like the collection, the cleaning, pressurizing, piping, re-injection. All of those are identified as best available techniques or technologies. Wherever you find a better available technique, a better available technology to handle the capturing, the cleaning, the piping, the re-injection itself, then please consider that. Best available technology in Canada might be your best available technology as well, or can also be false. So if I am using a technique in Canada, doesn't mean it will work in Ghana. Well, you should investigate that. It may and it may not. So we do not adopt the best available technology in certain country without thinking. No, we should actually evaluate that technique versus the country local standards and the country overall conditions. One of the things that I always actually remind myself with is the best available technique is the technique that requires less training, less expertise, less hassle. So if you have a technology that will capture 100% of the CO2 generated, wow, that's amazing. But this technique requires certain level of expertise. So you have to think, okay, my human resources, I have to push them up to a certain level. Well, this is cost, this is time. And what will happen if those expertise do not exist? Then I'm left with the best available technique, yes, but I cannot even work with it and I cannot handle it because I don't have the expertise for that. So again, when you check and choose the best available technique, we have to think in many aspects. One of them is the expertise needed. Do I have it in my country? Do I need to push my resources up to that level, and how? And what will happen if this best available technique is somehow I don't have enough experience, I don't have the expertise and the experts for it? Well, what would happen to that piece of technique? Well, you cannot use it. So you invested in something that is difficult to use. So the best available technique is attached to the expertise you have in your country, to the conditions you have in your country, and what is your ultimate goal as well. So a technology that I can use in Canada and it's working perfectly in Canada may or may not work with the same level in Ghana or whatever you are actually trying to adopt and to use. The main takeaways from this presentation will be identifying the major waste streams. Where are they coming from? Let me remind myself and you guys that the block flow diagram is your best friend here. And where in the process I can propagate the waste? Where can I utilize it? What kind of mitigation plan to minimize the chances of environmental issues? Is it there? Do I always have that environmental issues? Yes, we always have it. No matter what, you will have it. Okay, so make sure that you have a good and solid mitigation plan. Make sure that this mitigation plan is revisited every once in a while. Okay, and adopt the best available technology, the best available technique that will suit your country. So always evaluate the technique versus and against your standards, against your country unique situation. The best available technology is the technology that will allow you to convert waste into wealth, whether it's a reuse or whether it is a safety approach. And of course, at the top of all, it has to serve the environment. We are always looking at the environment as a gift that we have to take care of and deliver it to the next generations even better than when we receive it. Safety precautions has to be in place. What type of safety precautions? What type of techniques and best available techniques that I can use to hit the safety as well, to minimize any safety concerns, and also to maximize the idea of a safe workplace. Safety is not equipment. Safety is not numbers. Safety is an action plan that we are all responsible of. Well, I'm done for the slides and ready, Bernice, to the next move, please.
Thank you very much, Sam, for your presentation.
I'll stop sharing. Thank you.
Yes. Thank you. All right. I saw, please, if you have questions, you can still put it in the chat box, or you can raise your hand. We'll call you to ask your question. Let me just go through my takeaway from Esam's presentation. I think I heard something. Esam said dilution is not a solution. It just delays the impacts on environment and public health. So
thank you.
we have to try as much as possible not to focus on diluting it, but rather try and prevent it. That is what will help us to reduce our emission during gas processing. Then another point, there will always be a minimum or maximum emission, no matter the technology or method you are using. So we can't say, oh, I'm using the best available technology, so I'm okay, I'm not going to do anything. It is very important that at least at the design stage, at the production stage, at every stage, we should try and look out for these leakages so that we'll be able to mitigate them as we go along the project. And so therefore, we should not forget our contingency plan at the design stage. We should try and look out for them. Then another one is the SOPs. We should not just develop them and put them on the shelf. You told us that SOPs are living documents. So every day that you are working, it's like it's a room for improvement. So as you are using it, you are improving on your performance each day. So we have to make sure that our SOPs are always being used and are updated regularly. Then the last but not the least is that the PPEs are the last resort. We don't have to. When you go to the hierarchy of control, we start with elimination, we come to substitution, then we come to engineering control, before we come to administrative control. Then PPE is the last one. So we have to try and make sure that we are mitigating it right, or we are preventing it, rather than providing PPEs for use. Okay, so on that note, Samuel, you raise your hand first. So please, you can come in. You can also put your questions in the chat box. Then we'll read it out for Esam to attend to you. So Samuel, you can unmute and come in. Please introduce yourself. If you can be on camera, introduce yourself, where you are coming from, then your organization. Thank you.
Yeah, hi. Thank you. Good afternoon from Ghana. I'm Samuel Kofi Agbechiava from Environmental Protection Agency, Ghana. Yeah, right. Yeah, I think I put the question in the chat box, but let me, in the course of the delivery by Esam, he made mention of the source of the carbon dioxide from the amine unit. And I'd wanted him to explain the amine unit and what's the function of that. Thank you.
You're welcome. Okay, thank you very much. Please, the next person, you can unmute yourself. I can't see the name well, but from Kenya, NEMA. You can unmute yourself. Okay.
Thank you very much, Bernice. Thank you, Esam. That's a wonderful presentation. I just need to hear from you from your technical thoughts regarding a situation where probably the only promising field is already one, in the sense that there is only one IOC in the country. And this, I know we are not going to ignore environmental conservation in the interest of business people. But then I just want to understand, in terms of scale of operations, what would you look into to see how to do the aspect of recycling and reuse of some of these specific gases, like the ones you've just discussed, this sulfur, CO2, and nitrogen oxides. Just because I'm looking at it, that what would be the key? Basically, what I'm asking, have some form of modeling been done to appreciate economic feasibility, where you have a case of only one operator? And probably, is it that this particular operator should also do his own modelings and identify where recoveries can be done and to what extent, because I know the business case has also to be brought into discussion. Thank you.
Thank you very much. You didn't mention your name.
Sorry, Banis. I'm Selela Okoth from the National Environment Management Authority based in Kenya.
Thank you, Salila. Thank you very much. Okay, Esam, let me add some from the chat. Someone want to know what is the rationale of limiting the flare to 1 ton of sulfur dioxide per day in Alberta? So that is one question. Let me add another one, then you can address them before we take the next one. Okay, so Esam, could you please explain? Okay, this what has been asked by Samuel, so I will leave that one out. Okay, so some of the challenges emanating from the adoption of the stated BAT, that is the best available technologies, are lack of expertise and cost implication for the country that are able to adopt them. So I don't know whether it's a contribution or a question. If you want to find out if there's anything that can be done about it, or you are just trying to contribute. So Esam, please, you can come in and address these 4 questions. We'll pick the next session after this one.
Thank you. Best available technology is very expensive and requires expertise. That's true for certain types of technologies. That's very true. That's why we evaluate what is the best available technology for me to use in my country, and can I afford it? Well, can I afford it in terms of course, price, and in terms of expertise as well? Well, to be honest, nowadays, all the best available technologies that I am aware of are not expensive anymore. They are well searched and they are well studied. Engineers all over the world are trying also to make it as profitable as possible. Now, my advice is, when you evaluate the best available technology that your operator is proposing, you evaluate it in terms of expertise, in terms of cost as well. Well, so it is a cost versus a revenue studies. Okay, and the cost should also include, what do I need to push the experience or the experts in my country up to that level? Do I need to send them for a 4 years training? Do I need to send them for 2 hours training? Okay, and this training is included in the mitigation plan or no? Okay, and who pays for it? Okay, now let's remember our pillars: the government, the operator, the universities, or the research centers. In almost every country that I am aware of, they have governmental research centers. Those bodies and those entities should be supported in order to find the best available technology that fits actually your need. At the same time, it is, I would say, less expensive, as less as possible, and as more profitable as possible. So just evaluate the best available technology as a separate project. Just evaluate it, please, cost versus profit. And does it fit your country? A quick example, just a very quick example. They tried in Canada, they tried the best available technology. I was part of it at the university. We tried to evaluate this technology versus Canada. Is it gonna work in Canada? We found it, to be honest, less expensive than what we are doing now. So in terms of money, in terms of cost versus the profit, it was a good approach. Wonderful. It was not expensive. So the profit was more than the cost. Great. But unfortunately, we couldn't recommend it. Why? Because it does not fit our weather conditions. It's not valid for Canada because Canada is cold and this thing is not going to work. So the evaluation is unique. Every country is unique. Every project is unique. Every contaminant or pollutant is also unique. Whatever I'm adopting in Canada may or may not work in your country. So the evaluation, well, first of all, is it expensive? I don't think so. Okay, it is not expensive anymore. Your research institutes will help you always to determine the best available technology that suits your country and suits your project in general. Lack of expertise of the BAT or the best available technique and technology, the lack of expertise is always there. Always, we need to upgrade ourselves to a higher level. Okay, that's why engineers and experts and of course regulatory officers are not all the same. Some of them are actually following the most recent technology. Some of them are adopting the old technologies. There are schools, okay, and there are also limits. One of the reasons that we support a training like this is to push our expertise up to a certain level where we can actually make a better decision in our daily activities. So the training that you are attending today is ultimately has to push your expertise and knowledge up when it comes to the daily routine, the daily work schedule you have, the daily, I would say, challenges that you have. Amine unit. Amine unit is a very old technique to capture the CO2 and mainly CO2 and sulfur, clean up the gas. Amine unit is basically two parts, the absorption part and the regeneration part. And of course, as a note I'm taking here is to send a handout that explain the amine unit rule in the process itself. So Bernice, I appreciate if you can take a note about sending everybody a handout about the amine unit.
Okay.
So I'll push it for you to you actually, and through you, please, to the participants. Now, what are the rationals and for the 1 ton a day flaring, 1 ton of sulfur a day flaring in Canada? Like, how did we land in this number? Why 1 ton? Why it is not 2 tons? Why it is not half a ton, right? So basically with the current technologies, okay, this is the minimum we can achieve. Now, we don't have a better technology or technique that will allow us to flare less, okay? This is one of the researches that the government of Canada and Alberta Environment is adopting now, is how to put it down to less than 1 ton. Is there an available technique? Is there an available procedure? Let's put it this way. The other thing, the other rationale that we take it into consideration, we don't want to kill the process. We don't want to kill the project. Our job is not to stop the development. Because let's remember that energy is a national security issue. So you cannot say, well, because I cannot flare, well, because I flare 1 ton a day, this is too much, the project is not approved, and you know what, this development cannot happen in my country. No, no, no. We are not there, as I said, to stop the development. We are there to make the development more environmental friendly. That's all. but don't stop it. So the rationale there is associated to the current available technology plus the development itself. It has to continue because we have a demand for energy every day and every hour. We have an increase in the demand as we go in this life. Some of the solvents for CO2, of course, I will add that to the handout that will push to Bernice. So we will identify different solvents and what are the pros and cons associated to every solvent. This is very, very technical, very specific. If I want to add a point here, let me remind you that amine unit can remove CO2 and sulfur, yes, but the efficiency of that unit will never be 100%. There will be always leaks to the unit after, which is the dehydration, maybe in a perfect word. So how do I deal with this? Well, there is a best available technology. As we spoke in module 1, we talked about the solid desiccants, the adsorption process. So you can add it after the amine unit to handle any leaks. It will be part of your mitigation plan as well. It is there, and I use it every time I need it. Okay, and guess what? You will need it. So always have a plan A and a plan B. And if you can also have C as well, that will be perfect. The opposite conditions determine the size and the need for any clean up technique needed after the process itself. When it comes to nitrogen, I am a great supporter of capturing the nitrogen and re-injecting it as part of your enhanced oil recovery. So nitrogen versus CO2, again, this is a very deep technical discussion. I support the nitrogen more than supporting the CO2 injection. And again, the injection in the oil well is to increase the pressure so you can produce more and, overcome the depleting conditions of any oil well that comes with time. Skill of operation, how to do the aspects about the waste. Well, as I said, each waste is unique. Each project is unique, and each country and location is also unique. So if I identify waste coming at certain step in the process, accordingly, I can identify how to mitigate it and what skills do I need, what technology is available in my country or in the world that can handle this waste. I think all of those are my notes. If I missed anything, please remind me. Thank you.
Thank you very much, Esam. I think you have answered the first questions. Please, if you have any other question, you can raise your hand or unmute yourself and ask, or better still, put it in the chat box so that we read it out. Okay, so Samuel.
Yeah, Bernice, he didn't answer the amine question. He said the source of the carbon dioxide is from the amine unit, and I wanted him to explain what he meant by the amine unit and the function of the amine unit.
I think he mentioned, but you repeat it. Esam.
Yeah, what I will do in order to answer this, I will find a handout or more than one handout. Okay. All right. I'll send it to Bernice, and of course, from Bernice, it will go to everybody. This is, as you are aware of, this is a deep technical question, and I just want to be more focused on an overall. Probably in a certain period of time, the United Nations will arrange a technical training for all of those. Well, I leave it to Marisol to decide on it. And of course, it depends on the need. But I agree with you. The amine unit is problematic. Okay, I agree totally with you that amine unit has to be handled with care and has to be focused on more. Okay, you and I, we share the same thoughts when it comes to the process itself. And for everybody who's not a deep technical person, the amine unit is the first unit that will receive all the garbage with the associated gas. So whatever the garbage in the associated gas, it will hit the amine unit first. So the amine unit is the first line of defense, let's put it this way. That's why you have to focus on it way more than what do we do now. Again, let's go back to your block flow diagram. This will be the first block you will see. Okay, wonderful. So just imagine that this is the place where the majority of the problems will happen.
Yeah.
So take care, put a red flag there, and focus on it.
Okay, thank you very much.
Thank you, sir.
Thank you, Assam. Sabuni, please, you can unmute yourself, please.
Yes, good evening to you. My question is this, is there any cost implication in mitigating these wastes from the environment? Will you please answer my question?
Please come again.
My question is like this, is there any cost implication?
Cost implication, okay.
Yes, cost implication in mitigating the wastes like carbon dioxide, nitrogen oxide from the environment. I just want to know about that.
Okay, thank you. Mohammed, please, you can unmute and ask your question.
Good afternoon.
Afternoon.
My question is, you made mention of the reasons for re-injection, that it increased the oil well pressure. And he later made mention of the EOR, that it enhanced oil recovery method. So what does that EOR stands for? Please, can he shed more light on it?
Okay, thank you very much. Any other person? I think we have one in the chat box. From Felix, why we are living to use coal, why exists the BAT? I don't get it well. Maybe if you can throw more light on it. You are basing your question on yesterday's presentation. If you can unmute yourself and explain it to us. Then the second one, is there any methodology or guidelines to better identify the chances we have to minimize the environmental issues? If you have any options, you can give it to us. Okay, so Essam, you can answer these ones.
Thank you. I will. One of the notes that I like on the chat was talking about the scientific research, and it's actually very important to handle, the environmental issues. I do agree. It's a pillar. It's a major pillar. Remember, 3. We are talking about the operator, the government, and the research institutes. Without them, we will not receive, we will never be at the spot where we are now. Without the research, scientific research and scientific research centers or bodies. And again, most of the solution that I saw, they are coming from a governmental research body. So it's very important to look at those centers and at those establishments in a way that they might have a solution. So I agree with that. Cost implications in mitigating the waste. It's now the era of waste to wealth. So the cost implications are there, but it can be offsets with the revenue coming from the commodity you are creating after handling the waste. In other words, there is nothing called waste anymore. Everything has a value. It is just how do you implement the solutions available. There are many technologies available now that can handle the waste and convert it to a dollar sign. So please, let's remember that our main goal is to change the mindset of everybody and telling them that cost implications can be offsetted by the revenue coming from handling those waste and converting them to a commodity, basically. What do I want to do here? Yes, okay, so the enhanced oil recovery, the re-injection, what do you mean about enhanced oil recovery? So how about third handout? So let me push a handout to Bernice and then through Bernice to the rest of the participants about enhanced oil recovery in general as a concept and what are the best available technologies for that. So let me add a note here as a handout. So far we have 3 handouts, Bernice. The enhanced oil recovery is a concept where you want to handle the oil well pressure mainly, because with time the pressure will go down. Okay, so how do you actually increase the pressure, which is increasing the production of that particular well? Why did we leave the coal? Why we are not considering the coal as an energy resource nowadays? Well, most of the countries, they still use it. Some of the countries, they decided to stop it. Okay, now coal has several issues associated to it. They are mainly environmental. So can you imagine a country like Canada that shut down the coal industry because of environment? Yes, this is what the country did. So we're actually eliminating the coal as a source of energy. That means we are saving the environment and putting it in a better conditions. Why did they do that? Well, the best available technologies, the best available techniques are not mature yet to deal with coal as a clean source of energy. There are trials, there are lots of approaches nowadays, but we are not there yet. Till the minute we reach a point where we can say, okay, we are utilizing coal as a source of clean energy, till that point is available, we decided in Canada to shut it down. Methodologies or guidelines, they are available, and we can, I can share for the guidelines. The best is to go to a website that the government of Canada, the government of Alberta is adopting when it comes to environmental guidelines and methodologies available nowadays. This is Alberta Environment website. I would share it also with Bernice, and through her, it will be passed to all participants. It has a huge amount of guidelines, a huge amount of information that you can actually make use of and probably adopt. So let me write down here another handout for a website. Sam, I think the enhanced oil recovery is not applicable if you do not have large amounts of CO2. Alternatively, and better, you can inject the captured CO2 in it. Well, enhanced oil recovery is not the only solution for CO2 utilization. It is one of the options, but of course there is a limitation. You have a limitation on quantities, you have a limitation of, as I said, expertise, so you have to evaluate that as an option. Maybe when you are talking about small amounts, the best way is to convert it to methanol. Or maybe, to produce fire extinguishers out of it. It depends on we have to put the options in front of us, and we have to evaluate the options according to, first, the country, second, the project, third, of course, and the most important one is the environment. Okay, so am I utilizing CO2? Am I eliminating the CO2 problem and creating another problem environmentally? Or am I eliminating the CO2 safe and clean? Okay, that's why when you adopt one of the technologies to handle a certain waste, we need to take all the measures to make sure that the waste is eliminated. Second, we are not creating another problem. Three, it is profitable. I can make money out of waste. Okay, so that is the goal for every evaluation.
Thank you very much.
Yeah.
You can unmute yourself and come in.
Hello, thank you, Isam. I'm Faisal Abdi Mumin from Somalia. You talked about on standards and how the Canadian standards are heavy in terms of implementation and regulatory. Think about in a country with the potentiality of natural oil and gas with associated gas, but has no standards and regulations. What's your thoughts? What's your thoughts on such situation? Thank you.
Okay, Sam, please. I think it's the last question. You can wrap it up. Then we'll go for 15-minute break. We'll come back and come and do the exercise.
Faisal, my advice to you is look at the standards in Canada and in different. Again, I'm talking about Canada because I am aware of it, but I can also talk about Norway. Norway and Canada, they are both adopting, I would call it an environmentally friendly and environmentally safe standards. Now, my advice to Faisal and everybody is, if you can, talk to your nearest research center and let them evaluate the standards available in Canada and in other countries and see what fits your country in terms of standards. So adopt the Canadian standard, for example, when it comes to air, but probably you need to adopt the Norwegian standards when it comes to water. Who can do this? Well, the research, I would say governmental research body or the universities or maybe both, they can put the standards in your country.
Okay, thank you very much. I think Jonathan put something here about the cost-benefit analysis. He said cost-benefit analysis of most projects usually have cost implication at the beginning and benefits will be realized at the latter end. Yes, it's very important. And we are not only even thinking about the resource or the income, the revenue that will come back to us. We are also thinking about the Sustainable Development Goals, the SDGs. How are we going to make sure that we are able to have resource today, as well as future generation also have something to depend on. So on that note, we'll break for 15 minutes, come back and come and do the exercise for the day. Thank you.
Do you mind, Bernice, if I add one more thing to the cost benefit? We do not, well, normally we go straight to cost benefit of the project, and we have two things to look at. First, the hard part, which is cost versus profit of the technology that you are utilizing, but there are also soft measures. Soft measures are way more important for us because saving the environment is profitable. Health. Okay, if you can reduce the health concerns, then this is also a profit. So it's not always the dollar sign, how much I spend versus how much I will make. Well, there are also soft targets that we must achieve. At the end of the day, if Canada wants to look at the cost versus profit for the coal industry, then we will never stop it. But we looked at the soft targets as well. Thank you.
Thank you. Thank you, Bernice, and thank you, Essam. I think one thing that I also want to highlight from what Essam is saying is this partnership that the government can cultivate with your research centers and universities. That's why I'm really happy that a number of universities are with us today. But this is really something that we would like to promote and encourage, especially our government partners, to reach out and encourage your local research centers and universities to help you develop some of these best practice standards based on research of what other countries are doing. So I really appreciate Essam for emphasizing that since yesterday. We'll come back to this when we discuss governance related issues in module 3. But for now, I think Essam deserves a round of applause. And also to all the participants who have been very active in raising many of these very important issues. So